Good morning, Algebra 1. I hope you guys are having a fantastic day. I hope you understood everything well for yesterday's part of the lesson 7.4. And we're going to go ahead and finish up the second half of lesson 7.4 today. That is division properties of exponents. So for today, you're going to need paper, pencil, calculator. Again, you can use the calculator.net textbook. We're going to be on page 441, and then homework 65, which will be online, and again, that'll be due on Wednesday, April the 29th. So please, again, make sure you are using your time wisely because you have a test on Friday, so you cannot lag and get behind this week. All right, so we're going to go ahead and get started. All right, we're going to go ahead and get started. So the first thing we're going to learn today is raising a quotient to a power. So we're going to take something. So quotient means dividing. So we're going to say A divided by B. And we're going to raise it to a power, something that you've already kind of done in your product. So we're going to say raising it to the n power. So we've already done this before. We haven't understood that when we do not see an exponent, it has an understood exponent of 1. So when that's not there, that's our understood value. We have learned already when you have a power to a power that we multiply the exponent on the outside attached to the parentheses to each of the exponents on the inside. So this becomes a to the 1 times n over b to the 1 times n, which now becomes a to the n over b to the n. Then if they had the same bases, then we would use the same rules of which we have learned thus far. So now we're going to teach you how to do that and how to simplify. So we're going to go ahead and do just a few together. So we're going to do 3 over 5, and we're going to raise it to the third power. And then we're going to do x over y, and we're going to raise it to the fifth power. And then we're going to do a over b, and then we're going to raise it to the 1/2 power. All right, so here are 3 examples. So again, remember when we do not see exponents, we have an understood exponent of 1. And if you need to write them in when you're doing your problems and working them out on paper, this would be my best solution for you to do, or suggestions. We're going to multiply the 3 times the 1 and the 3 times the 1 down here. So now we got 3 to the 1 times 3 over 5 to the 1 times 3. So we're multiplying our exponents to get the new one. So now we got 3 to the third over 5 to the third. And now we're going to simplify. So 3 to the third power means 3 times 3 times 3 again, which is 27. And then we're going to simplify 5 times 5 times 5 again is 125. This does not reduce, so this is our final answer. So here, again, we do not see any exponents. We're going to go and put our understood 1 exponents in there so we're not confused. We're going to multiply the 5 times each of the exponents. So we got x to the 1 times 5 over y to the 1 times 5. Then we'll simplify. 1 times 5 is 5. And again, 1 times 5 is 5. Fifth over y to the fifth because they are not the same bases. And that's a base y. Then we're going to take our a and b. We do not see any exponents, so we're going to put an understood exponent of 1. And we'll multiply each of those exponents by 1/2. So we got a to the 1 times 1/2 over b and 1/2. So 1 times 1/2 is 1/2. So a to the 1/2. And 1 times 1/2 is still 1/2. So b to the 1/2. A and b are not the same base, so therefore we cannot do anything else. This is our final answer because, again, there are no negative exponents, so we stop off where we are. All right, so we're going to go ahead and continue working with a few additional problems. All right, here are 3 additional problems that we're going to go ahead and do, and we're going to follow that same rule that we were using in the previous 4 problems, or 3 problems. All right, this has an exponent, but this does not. So we don't see the exponent, so it has an understood 1 exponent, so I'm going to leave it there. we're going to use our rule. We'll distribute and multiply the 3 to the 2/3, and we'll multiply the 3 to this 1 down here. So we got z to the 2/3 times 3 over 5 to the 1 times 3. So all I did was showing multiplying my exponents on the inside by the power that it's being raised to on the outside. So we'll do 2/3 times 3. So if you need your calculators, you can do that. It will be 2, but I want to show you. We're just going to go ahead and put this in here. You can see it better. All right, so we're going to do 2/3 times 3. Well, my calculators act like a ding ding times 3. It's going all the place. And you get 2. So this becomes z to the second power, and we know 1 times 3 is 3. We cannot solve z squared, but we can solve 5 to the third power. So we're going to leave z squared, and then we're going to do 5 times 5 again, which is 125. We have no negative exponents. Final answer. All right, so we're going to move along to our next one. Again, this 4, we do not see an exponent with it, so we're going to give it an understood 1. The x has an exponent of 3. So we're going to multiply the 2 times the 1 and the 2 times the 3. So we got 4 to the 1 times 2 over x to the 3 times 2. So again, we took their inside exponents and multiplied them by the outside power. So then we've got 1 times 2 is 2, and 3 times 2 is 6. We can solve 4 squared. We know what 4 times 4 is. That's right, 16. And we can't do anything with the variable being raised to a power. We have no negative exponents. Final answer. All right, so we're going to move again. Both variables inside, both a bases, have an exponent that we can see. So we're going to multiply 4 times the 3/4 and 4 times the 5. So we got a to the 3/4 times 4 over a to the 5 times 4. So again, we took the exponents on the inside with the bases and multiplied it by the exponent on the outside, or the power it's being raised to. So 3/4 times 4 is 3. And 5 times 4 is, that's correct, 20. Now these happen to have the same base of a, so we can simplify using our rules. The exponent of our denominator. So again, we'll take the exponent of our numerator, which is 3, minus the exponent of the denominator, which is 20. And now we've got 3 minus 20, which is negative 17. And not have a negative exponent. So remember, there's a 1 up here that we don't see a coefficient of 1, so the 1 stays. And the a goes to the bottom and gets a positive exponent of 17. So this is our final answer. All right, so we're going to go ahead and move to our final portion of our lesson. All right, here are the final 5 problems that we're going to do, and this will complete our lesson for today. All right, so first of all, you're going to notice on this first one that our exponent out here is negative. So what we're going to do is make sure this is not negative. So to change this to a positive 3 on the outside, we're going to take this entire fraction on the inside and flip it. So he'll say y to the 4th on the top, and he'll say 2x to the 6th on the bottom, and now he'll be raised to the 3rd power. So now there we go. Now we don't have to worry about negative exponents anymore as far as multiplying, and it's all taken care of. So we check, our y has an exponent of 4. Our 2, we don't see the exponent, so we're going to go ahead and put it understood 1. And then our x has an exponent of 6. So we're going to multiply 3 times the 4, 3 times the 1, and 3 times the 6. So here we go. We got y to the 4 times 3. So 4 times 3. And on the bottom, we've got 2 to the 1 times 3, and x to the 6 times 3. Right? So we move over here. We know 4 times 3 is 12. And then we're going to do 2 to the 1 times 3, which is 3. And 6 times 3 is 18. With the variables, we can't simplify them any lower. But with this 2 to the 3rd power, you can solve 2 to the third power. So your final answer, our top, we can't do anything with y to the 12th, but we can solve 2 to the third power. So 2 times 2 again is 8, and then we have our x to the 18th power. And this would be your final answer right here. All right, so let's look at our next guy over here. So we have a negative exponent. So Fabian, what should I do to this fraction on the inside? That's correct. I'm going to go ahead and flip that fraction on the inside. That negative 2 on the outside. Since you said to flip the fraction, what happens to this negative 2, Fabian? That right, it becomes a positive 2. So now I'm going to go ahead and assess my problem I got going on here. My 5, I don't see an exponent, so I'm going to put a 1. My b, I don't see an exponent, so I'll put 1. And my a, I don't see an exponent, so I'll put a 1. So I'm going to multiply 2 times each one of these individual exponents. So now I've got 5 to the 1 times 2, b to the 1 times 2, over a to the 1 times 2. All right, so I'm going to go ahead and multiply. 1 times 2 is 2, and 1 times 2 is 2, and 1 times 2 is 2. All right. So 5 squared we can solve. It means 5 times 5, which is 25. And then we got b to the second over a to the second, because again, we can't do anything with those variables. So then this would be your final answer. Everybody, I hope you're doing okay and this is, working smoothly for you. All right, we're going to move to the next problem up here. All right, so again, we have a negative exponent out here. So Amaya, what must I do to get rid of this negative exponent? That's correct. I'm going to take the fraction inside and I'm going to flip it. So what's on the denominator, which is 3y to the 4th, will go to the numerator. And what's in the numerator, which is that negative 2, x to the 1/6, will go on the bottom down here. All right, and once I do that, Amaya, what happens to this exponent? That's right, becomes a positive 3. All right, so I'm going to check this guy out. This 3 doesn't have an exponent that we see, so I'll put it as a 1. The y has a 4. It's a 2. I need to put that there. Bam, give it a 1. And x to the 1/6. So I'm going to multiply, 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 multiply. All right, so this one can be a little tricky. That's the reason why I chose this one, because we have this negative here, and I want to show you how to handle that guy. So on the top, we got our 3 times 1 times 3. We got our y times 4 times 3. Now, as we move down, we have this negative sign, and he is all to his lonely self. We know he's to his lonely self because there's no parentheses saying it's not like negative 2. That's when I would say the negative goes directly with the 2. But when we just see it like this, he stands alone. Then we got the 2 being raised to the 1 times 3, and we have our 1/6 being multiplied by 3 as well. All right, so we're going to go ahead and get started. So 1 times 3 is 3, and then 4 times 3 is 12. And on the bottom, we got our negative. He ain't going nowhere. And then 1 times 3 here is 3, so 2 to the 3rd. And then 1/6 times 3 is 3/6, which is a half. So if you put this in your calculator, 1/6 times 3, you'll get a half. Okay, I'm going to bring the screen up just a smidge. All right, so now we're going to solve 3 to the 3rd power because we can. We can do 3 times 3 times 3 again, and we're going to get 27. And we got y to the 12th, so we can't do anything with our variable. And then we got our negative down here. Again, he just comes for the ride. Then we got 2 to the 3rd power, so 2 times 8. And we got x to the 1/2. So positive exponent, 27 over 8 does not reduce. Final answer. If 27 over 8 happened to reduce, we would reduce. All right, so we're going to go ahead and move to this middle problem. So Cheyenne, what should I do here with this fraction in order to not make this negative? Correct, I'm going to flip it. So my numerator is going to come here, and my denominator is going to go down here. So Cheyenne, what happens to this exponent out here? Correct, it becomes a positive 3. All right, so I'm going to look in my guy here and see that I do not have an exponent with my 3 visibly, so I'm going to put the 1 there. Same thing with my n, and same thing with my 6. So I want to multiply 3 times each of these exponents on the inside. So when I do, I got 3 to the 1 times 3, and n to the 1 times 3 on the numerator. And on the bottom, I got 6 to the 1 times 3, and n to the 2 times 3. So then I'm just going to do my multiplying. 1 times 3 is 3, and 1 times 3 is 3. Add those values, 1 times 3, 1 times 3, 2 times 3 to give me 6. Alright, so now we're going to simplify them. We can solve 3 times 3 times 3, which is 27, and then we got n to the third. And we're going to do 6 times 6 times 6, which I do believe is 216. And then we've got over n to the 6th. You'll notice that you have an n to the third over a n to the 6th. So what we have to do here is divide these exponents out. So what we're going to do is going to, for now, keep our 27 and our 216. We're going to leave this alone for a second. Since my variable that they have in common the same base is n, and this did not make a whole number right now, I'm going to keep the n on the top and take the top exponent, which is 3, minus the bottom exponent, which is 6. So do that first. If your exponent's negative at the end, then we can switch it around. But just start by writing it on the top and then showing your subtraction up here. So again, I got my 27, and then 3 take away 6 is negative 3 over 216. Well, I have a negative exponent, so it can't stay negative. So the n has to go to the bottom, making this n to the positive 3. Now I need to check to see if my fraction, 27 over 16, is going to reduce. So I'm going to bring this down. You guys can see. Put my fraction bar in here. I'm going to put 27 over 216. And I'm going to check to see. And it does reduce to 1/8 because 27 times 8 is 216. You can also do 27 divided by 216. Some of your calculators may give you 0.125, which is the same as 1/8. And again, you can use that fraction calculator on that calculator.net that will help you out. This reduces to 1/8. This becomes 1 over 8, and then my n to the third. Final answer. I know that was a little tricky one, and there was a reason why I did it, because I wanted you to be able to see how that problem worked. Alright, so we're going to do our final one. We have an entire fraction being raised to the 0 power. So if anything raised to the 0 power, what is that equal to? That is correct, Miss Amaya. It is 1. Anything raised to the 0 power is 1. We don't have to do anything in here because this whole entire fraction is raised to the 0 power, which makes its value equal to 1. Alright, so that is our final lesson for today. So you have homework online tonight. We have a test on Friday, and you will also have a review available to you online. So please make sure you take advantage of all of that and have a fantastic day.